I'm your host, Helen King. Developments in open source software happen because of the power of community. Developers can access code and create functionality and applications that will drive improvements and opportunities along a supply chain. Many technology vendors are embracing this model to provide platforms to manage your business. But how do you proceed? In this webinar, we will have a panel and we will discuss unravel the mystery of open source technology. Before I hand this over to Laura and the rest of the panel, there are a few things I want to cover with you. We are recording today's session and we'll post it to our on-demand webinars page. You can visit our website to listen to this and any of our other webinars. Additionally, we'll send the slides to all attendees within 24 hours. We encourage you to share these slides with others in your organization, and if you have questions, please reach out to Laura or myself to set up a discussion. We want to hear your questions about our findings. Please post to the Q&A function or the chat to the left of your screen on the bottom. We've left time at the end of the webinar to address your questions. Finally, we'll be live tweeting the webinar, so if you would like to participate in the social media conversation, you can follow at SC Insights, LLC, and use the hashtag SCI webinar during the event. Now allow me to introduce our host, Laura Ciceri, founder of Supply Chain Insights. As an enterprise strategist, Laura focuses on the changing face of enterprise technologies. Her research is designed for the early adopter seeking first mover advantage. She comes to the stage with over 40 years of diverse supply chain experience. Welcome, Laura.
Hey, thanks so much, Helen. And I want to welcome Glenn Jones and Dave Schumann to my panel today. Glenn, can you check in with us? I want to be sure I can hear your voice. I'm worried that we have Glenn on mute, Helen. Can you work with Glenn to get him unmuted?
I will.
And Dave, let's do some introductions. So, Dave, I've known you now for almost 2 decades, and you've been working with Cloudera on open source. Tell the group a little bit about yourself.
Hi, Laura. Thanks. So my name is Dave Schumann. I'm with Cloudera. I'm our industry lead for retail, manufacturing, and sensor-driven use cases. And it's a really neat position within an innovative open source company where we have the opportunity to help customers look at these new types of processing frameworks, these new types of data that they want to ingest, these new ways they want to deliver value back to the business, and identify how they would do that with the open source, the Hadoop stack, as it were.
And how long have you been working with open source, Dave?
About 3.5 years now. So I come from a much more traditional background. I was a DBA. I was a business intelligence architect. And so my background and my relationship with data was, I have to say, very structured, very formalized. And this was a pretty radical shift to start to look at how do you take on these new types of processing frameworks? How do you use data differently? And most importantly, how does an organization change to be able to leverage these kinds of technologies? How do you get what Google and Airbnb and Facebook and LinkedIn have done to pivot their data to become agile with working with data?
Yeah, and we're working to get Glenn unmuted, but I invited Glenn to the call today. Glenn's the CTO for SteelWedge, and SteelWedge wrote their new software on open source, and I've asked Glenn to come and share his perspective on the use of open source and the evolution of supply chain code. So we're getting Dave, we're getting Glenn dialed in, so we're going to go ahead and then we're going to have Glenn to come in and join us. So, just to refresh, we do monthly webinars. This is actually our 60th webinar. All of the webinars are archived, and what we're trying to do is be the first place the supply chain visionaries turn to get new insights and drive innovation. I invite panelists based upon knowledge. So And this webinar is not an endorsement of Cloudera or SteelWedge. It's really because I know Dave and Glenn are knowledgeable on the subject. And what we try to do is we use our research as a backdrop to drive discussion in the industry. Our goal is to be the independent and open analyst model. So we do quantitative and qualitative research, and we do facilitation of small groups. And what we do is we share that openly, and so we don't believe research should be behind a paywall. This webinar will be shared on YouTube, SlideShare, and on the Supply Chain Insights website, and we invite you to share it within your organization if people aren't clear on terms like Hadoop and Spark, and they don't understand the evolution of open source technology or Apache. This is really designed as an educational webinar so that you can become more conversant and share and start to ask the question about how does open source really help with the evolution of supply chain applications. So I'm going to get started, and I want to just start with some basic research to set the stage. When we ask companies to tell us about their current business pain, and this is from some research that we did across many studies, we see that volatility, alignment, data, talent, and visibility are all top business pain. And today we're going to really focus on the ability to access and use data. The average company has 2 to 3 enterprise resource planning systems, often called ERP, and also multiple advanced planning systems. And one of the issues that we find is data sits in those silos, and we've made the silos more efficient, but we have not made it more effective. The other thing is when we find companies that are working well, they're able to use data and they're able to drive higher levels of visibility. But data today doesn't look like data of a decade ago. In fact, data comes in clouds and cloud-based applications, and cloud-based applications allow us to go across organizations. It comes in streams, and so we have streaming data. Most of our legacy supply chains are batch-based, and so streaming data allow us to use things like Internet of Things data, GPS data, telematics data, sensor data, and to be able to do that. And then we also have data pools within the organization where we pool data, and that allows us to get data across different disparate systems in a heterogeneous environment. And so one of the things that we have to think about is, our traditional definitions of data was really around what I call the traditional 3-letter acronym stack of CRM, SRM, ERP, APS, PLM, and we automated data around those individual applications. But that's not sufficient. So we have to think about clouds and streams and lakes and the definition of analytics that can sit between the operational investments and our workforce productivity tools, things like Microsoft Office and Access and Excel, and really break down those Excel ghettos. Now, if we think about the traditional supply chain applications, they're proprietary, they're closed, they're batch, they're linear, they're fixed, they're inside out, and they're dependent on hard standards and coding of data. In fact, many times people have lots of master data guys, that hard code data. And so our current and traditional supply chain thinking has been about transactional data and stuffing transactional data into rows and columns and hierarchical representation with primary keys that have fixed hierarchies. And if we think about the insight stack, we've been looking at descriptive and predictive analytics, but really haven't gotten into prescriptive and cognitive analytics, which allow us to drive different levels of insights, particularly on structured and unstructured data as we're dealing with data pools. And our current integration of the extended supply chain has been one-to-one linear. So my argument today with open source is it doesn't have to be. I think there's a need for us to take a hard left in supply chain thinking to really pursue architectures that are distributed, that are open, that are outside in. And when I say outside in, it's not about the enterprise, it's about the customer, it's about the customer's customer, and it's about market data, and it's about the supplier's relationship, and not only that supplier, but its relationship with multiple tiers of suppliers, and that supplier's relationship with the logistics provider, and that supplier's relationship of the logistics provider and perhaps the drayage provider. And so outside in allows us to sense and use external data. And most of the external data is streaming data. And so we're going to talk a little bit about that. And the streaming data doesn't fit very well in our linear, traditional, relational databases that we've adapted for many years. But the biggest issue, I think, is us and the fact that we have to learn a new language and we have to redefine supply chain processes that move outside in. So before I continue with the use cases, Glenn, I think that you're in now. Can you say hello?
I am on. Yes, hello.
Awesome. Okay, so give the group a little bit about your background and a little bit about your work with open source and your perspective on, the hard left and the right and our traditional view of supply chain.
Yes, so I'm with SteelWedge. We do demand planning, supply planning, and sales and operations planning. We build applications delivered in the cloud. And we've recently completely rebuilt our stack on top of open source technologies, including Hadoop stack. And this has enabled us to be able to pull in a lot of different data types. We've done work with sensors, Internet of Things, some work in the agricultural space, pulling in data from feeds from fields and farms, being able to pull in Twitter feeds and be able to correlate that back into the demand planning process and understand, consumer sentiment. And so the new stack that we have has really enabled us to pull in a lot of different and innovative data types and be able to enable our customers to really engage with the outside-in planning process.
So in that evolution from the more traditional relational database to the adoption of open source and Hadoop, what did you learn, Glenn?
Well, a lot of it was that you can organize data differently and that you can create different types of queries to pull up unique and I guess we'd call it mining data. But the other thing is we've learned that we can apply a next generation of algorithms, more machine learning algorithms, and be able to handle a lot more data and feed data into these algorithms. It just wasn't possible in the previous generation of architectures.
And why wasn't it possible in that prior definition, when we were still dealing with linear optimization and rows and columns? Why was that not possible to go to that more insight-driven approach?
The relational databases, you had to have very structured queries. You had to structure the data. It was very difficult to handle the unstructured data types. And so everything had to be kind of pre-programmed, where in this new architecture, you don't have to spend a lot of energy and time pulling in these new data types and being able to make sense out of them. It's the Hadoop architecture and then the technologies built on top of those architectures have really enabled us to better, not only manage and input these new data types, but also supply them into our more advanced processing algorithms. And it's also enabled third parties. So, we don't have skills in agriculture, for example. We don't have a data scientist that understands agriculture, but our customers do. So they're able to develop their own algorithms in Python, for example, or in maybe R, and be able to leverage the data that we've pulled in from the different sensors, and also the structured data on top of that, like traditional forecasts and orders and inventory.
Awesome. Thank you, Glenn. Now, Dave, you've been working in this world for a long time, right? And when I first met you, we were working on relational databases, and you were working on solutions like Orchestra for point-of-sale data. What have you learned from the movement of what I call the hard right to the hard left? What's the difference, and what can people learn?
Well, I think it's important that you decouple the generation of and curation of the data from its consumption. So if you think of this, and you get all these catchy little phrases like data is the new oil, but in that you still have to, if you want to have jet fuel, you got to refine that in that processing. And so in this traditional world, we had to couple how we were going to use the data with our entire ingestion framework. We thought about what we were going to do with data before we even had a chance to see it or to explore it or to develop any hypotheses around that. We built out a business plan. We put a spec together. We threw that over the transom to our technologists who worked through their ETL processing on that. And not only was that process time-consuming and expensive, but we often didn't get a satisfactory result as an end product of that. And so what this framework does is allows you to decouple how I'm going to use the data from my ability to ingest and bring it in to a system where I can store and start to work with it. So if I'm looking at a Gen 1 RFID or Gen 2 RFID tag, if I'm dealing with new telematic data that's coming out there, I get to explore and understand what the data looks like, to be able to visualize that data using standard BI tools, your clicks, your tableaus, your MicroStrategies, your Cognoses that can visualize that data. And then I can start to build out advanced frameworks on that. But in each case, I'm working this modularly with that framework. Glenn talked about Python and R. Any of those sort of data science or advanced analytic platforms now can also operate on that data. And that decouples, it stops us from thinking of this as I'm going to load data into a database, and then I'm going to take data from my database and I'm going to put it into my machine learning tool like a SAS or an SPSS. In this pipeline now, SAS and SPSS can go talk to the data that lives in my data storage layer. And it's just we talk in the open source world, we talk about this being the difference between schema on write, which is I've determined what the data is and how I'm going to store it, and I infuse the schema into the data as I'm writing it into my storage layer, with what's called schema on read, which is I ingest the data. It's like copying a file to an FTP server or to my C drive, and then I start to define things about that file that allow me to use it. And that is that schema on read agility that you get.
I love that definition, because I think there's a lot about data patterns that inform us. And when I think about how we hard-coded linear optimization and stuffed the data in rows and columns, assuming we knew what the relationships of the data were, and that the relationships of the data didn't change over time, I think we missed those relationships. So Henry asked the question, he says, well, we still have to get demand and constrained supply information from somewhere. And absolutely we do. And the average company has 2 to 3 systems. But Glenn, being able to digest on read allows us to learn from those patterns. Would you agree? Does that make sense, Glenn?
It does, yes. That's exactly right, and that's exactly how you do it now. As you pull data in, you understand, and you can correlate that data with other data types that you have, and so you can start looking at, for example, the impact on the supply plan or the impact on a demand plan.
So, Henry may have traditional APS systems that give him traditional demand and supply data, but bringing that into an Hadoop framework and open source would allow him to understand the patterns as well. So I want to just go through some use cases. So to be sure that we've level set the group when we talk about structured and unstructured data, this is a rules-based ontology for cognitive learning. And so as we come up the stack on being able to drive insights, what we have is the ability to drive many-to-many relationships and map the context to data. We could not do this within structured rows and columns, as Glenn was talking, and we had difficulty being able to have this be an adaptive learning system. This is where supply chain processes are going, and so the adoption of open source allows us to get there faster. Now, the other thing I want to do is go through some use cases, and then we're going to go through some education about open source. Many times people will say, Well, Laura, what do you mean by unstructured data? And one type of unstructured data is sentiment mining. So this is a case study from our Global Summit of Lenovo. And Lenovo listens to social data around the world about their new products. So they've got a cross-functional team that gets together weekly, and they listen for what are the trends around the world about their products. Now, this social data is unstructured. You'll notice that it comes in a lot of different shapes, and listening and pattern recognition on text data is not something that fit within our conventional formats. And in fact, very few companies, I only know of 9, actually have listening posts to be able to use sentiment data. But sentiment data tells us the true voice of the customer. Now, another case study that we had at our summit last year was Linux International, and Linux International is redefining service. And originally, when they talked about heating and air conditioning units, they knew that they were always going to fail at the beginning of the summer and at the beginning of the winter, because that's when you turn on an air conditioning or heating unit and we find out that clunk clunk, it doesn't work. And we could never forecast spare parts effectively. So the first thing Linux did was they defined the climate zones to be more granular so that they could have a better sense around weather, and weather is a type of unstructured data. Then what they did was in the HVAC units, they would put sensors into those units that could tell the health of that unit, and the goal was to redefine the service supply chain. So instead of you calling up a serviceman and maybe waiting 4 hours, when you would like to be at work, and the serviceman coming based upon a scheduled appointment, their distributor would knock on somebody's door and say, based upon the sensing of the unit and based upon the weather conditions, we believe that you need a service. Maybe it's a bearing or maybe it's a filter, but we have a diagnosis and we'd like to make an appointment to use our service mechanic to repair what we believe is a failure on your HVAC unit. Now, this is predictive service, predictive maintenance, and can also be applied to digital manufacturing. But what's key here is the use of unstructured data and streaming data. That sensor data is all streaming data. And the last webinar we did was on the use of streaming data and what we're going to call Apache Spark, which basically takes containers on the water and the sensors on the water with the AIS vessel location and brings it into a framework which allows us to look at streaming data to be able to better predict arrival. And this was a case study that was presented by Savvy. Savvy does a lot of work with the Department of Defense where they combine streaming data on Apache Spark with machine learning to give real-time prediction of trucks and containers. So case studies of unstructured data with streaming data, but not something that could be used and applied with the traditional supply chain processes. Now, Dave, this is your slide. To be able to talk about open source, right, we've got to learn a whole new language, and it looks a lot like Fazoo, right? I mean, terms like Python and Hadoop, and how do people learn this new language, and what do these all mean?
Well, and this is sort of interesting because as you start to see, this is the growth of projects. We talk about Hadoop as being this modern framework for data and analytics. And the reality is it started with a couple very core projects from Doug Cutting and Mike Caffarella when they were working up at Yahoo, and based on a Google white paper. They created that little piece on the way left over there in 2006, which was that core storage and processing framework. And so over time, a community of contributors has sort of coalesced around this. They look at this and they say, I have something new that I want to do here. And they add and they create a project around that. And if that project gets people that are interested in it, you start to have a community and a project, and it moves through its incubating phase, into beta, into becoming a top-level project. And so this is each of these little words that's on there. So ignore the funny names. We really should not let nerds name things. Each of these serves a function. It serves a capability within a data platform around query, around search, around machine learning. And so I'd like to take that, and yes, your technologists will want to know, are you using Spark? That becomes important. I kind of pivot that framework, Laura, to sort of this next way of looking at it, which is what do we want to do with data in the platform? How do we want to bring data in? What is our ingestion frameworks around that? So now those words like Kafka and Scoop and Flume, you can put a label on that. It's metadata. We can say that's all about how do I ingest data in the platform. And so is it streaming data? Do I have to have a subscription publication model? Am I tying in data from my relational systems? Well, that's kind of what those three words of Kafka, Scoop, and Flume all refer to, which is frameworks for data accessing. How do I transform data? So MapReduce was the core and the seminal framework in here, but Hive and Pig became query languages. Spark is a whole new framework. I'll talk about that a little bit more in there. We want to do things on the data, like use SQL. If we don't want to be coding in Java if we have business analysts. They want to use their business intelligence tools. So I want to connect Click or Tableau or MicroStrategy to this data and be able to use it in my visualizations. Search. There's a great use case that we did with Siemens that talked about how they made a 360-degree view of their supply chain by enabling search on all the different nodes across the supply chain where data was flowing. And now your analysts are using the Google query box to explore their data and identify where things are. So Spark, we'll have a whole topic in there as we start to say how can we use this. And it's such a exciting and vibrant community that has adopted and worked with Spark as sort of these frameworks for modeling and even serving. And at the core, you say, well, I've got to store data, and I have to store data in such a way that it matches my access patterns, whether I'm going to be doing long-running scans over the data, whether I want to do real-time serving of that, or even these kinds of columnar stores. That's the Kudu that sits down there. So Spark,
now, let's have Dave join in here. Now, Dave, what did you use in the rewrite of SteelWedge?
We used the core Hadoop, so we used the MapReduce, and then on top of that we layer Impala, we layer Solar, which is an index and an index search. It indexes everything, and then we also have another technology that Dave doesn't have on here called Kudu, and what Kudu does is in the world of planning and supply chain, or in the world of ERP, the traditional Hadoop stack was a write once, read many. And so you're constantly inserting new data, whatever kind of data that is. But in the world of supply chains, you have to do updates. So you're constantly updating a forecast, or you're updating an order. And so we also, and again, we use the Cloudera stack, and we use the Kudu list. I guess it's listed at the bottom, and that enables us to not only just do writes, but also enables us to do updates. And then on top of that, we use Spark, we use Python, we use R, and then we also use sometimes more traditional Java-based applications.
Great, thank you. Okay, Dave, let's go on. So why?
Well, so you meet the framework with the needs, and so one of the nice things again is you have these. This is a community of people who are passionate about how to work with data, that they're developing frameworks that do just that. And so Spark is one of those that has really helped the whole open source community adopt and work with data in new and exciting ways. And if you think back to the roots of what Hadoop was, Hadoop said, I have distributed storage, lots of servers, distributed compute, memory servers that were sitting on each of those, compute that was sitting on each of those servers. And that was really how MapReduce sort of framed itself out. What Spark says is, hey, you also have memory sitting in a distributed compute environment. And so you can bring processes into memory and operate on them in a distributed, scalable fashion. And this all of a sudden opened up so many interesting workloads in this open source technology now. And again, it's some of this is still back into the data preparation. We do get data through request response, and batches still happen, but the streaming, the ability then to add things like machine learning on top of that, to build out graph representations of your network within there. And this is probably one of the fastest growing and project with the most contributors that tie into that within this open source framework today, because of all the capabilities that it brings to this data asset that you're curating.
So, Dave, let's talk a little bit about what's Apache, right? A lot of people on the phone have never heard of Apache, right? So, what is the foundation, and how does it work?
Sure. And so there are a number of open source license examples out there. So if you think of the MIT license or the Mozilla public license or GNU or Clips, Apache is one of those organizations. It is a foundation that allows people to create and collaborate on software, but do that where the licensing on this is very open permissive. And so this gives you a governance foundation for how you're going to develop software in a very distributed compute environment. Probably one of the earliest examples we saw on this is with now the most popular operating system out there with Linux, doing the same thing where you're able to have contributors from all walks of life that are driving innovation within this sort of stock elements of release. And this is different from the common proprietary top-down management of software where the innovation is controlled by any one single organization. And so Apache is one of those foundations that allows you to do that.
Yeah, and one of the questions that I ask SAP, and I'm not getting a good answer, and one of the reasons why I'm going to SAP Insider is the release of HANA with Columnar Store allows us to bring commonly used transactions into memory, which helps us with reporting. And of course, with the persistence and the security of ERP, that makes a lot of sense. But, Glenn, for supply chain applications, time phase data, or the use of unstructured data, what do you think happens to SAP HANA versus Apache and the open source world? What do you think happens?
Yeah, it fundamentally, it can't support those data types. So you wind up having to pull data from multiple different data sources. You pull data out of the columnar data store, for some kinds of reporting, but then you have to cross that with a Hadoop stack, for example, to be able to blend in the unstructured data, the other data types you're storing there. There's no real reason to do that. At least we've found for the planning applications, everything can be stored in the Hadoop stack, and there's, you can still get the columnar type queries out of the Hadoop stack. So we compete with SAP on that front, but we have our ability to manage a broader set of data in one place with one access is far superior to just having a separate relational store and then a separate columnar store.
Yeah, it'll be interesting to see what happens because, Dave, the open source code is so much more cost effective, right? It's like 1/5 the cost or something like that. And what's the ratio that you use?
So your mileage may vary, but on this, we look at saying that it's in the thousands of dollars per terabyte when you think about what a Hadoop stack is for your ability to store and process data. And you can compare that with any of the closed source vendors around what their cost processes are.
Yeah, our cost has gone down significantly of deploying and maintaining these systems.
Okay, and the Apache Foundation really allows the governance for this, right, Dave?
Yeah. So if you try to think about this, and you're going to hear as you start to get into open source, people say, well, I'm a contributor on this, or I'm a committer, or I'm a member, or I'm a PMC chair. What does that mean? Well, those are your governance models for how do you align the interests of people who are working, in this case, distributed all over the globe on a set of initiatives. So as you want to add features into Scoop so it can talk to more relational database products on there, you need to say, how does it fit in the roadmap? How are you going to tie that into security models? How do you do that into resource management? And that's really where the role of Apache comes into this is helping to coordinate those efforts. What's neat about this is that you earn your positions in here. So as you contribute more and more, you earn the right to become a committer. You get elected to become a PMC member. You get elected to be a chair through the community of people who are invested in that particular project. And if you ever get a chance, there's a great essay that Eric Raymond wrote on this topic when he was talking about the growth of Linux versus the Unix operating system called the Cathedral and the Bazaar. And you can see how that sort of bazaar mentality, that's a B-A-Z-A-A-R, sort of an open marketplace where all these ideas and innovations brought together, versus this sort of the concept of a fiat where the authority, the cathedral, tells you exactly which way you're going to drive your software innovation.
Great. Well, let's go to an open discussion. We've got.
Let me add to that.
Glenn, you have a point?
Okay. Yeah, just one other point on that. So, we use a lot of the Hadoop stack, again, the Cloudera, but Kudu was immature. So as a software vendor or as a software in the cloud vendor, a lot of times we will find bugs. We'll fix those bugs. We'll put it in our internal version, or we'll add a small feature, and then we submit that feature back to the committers. They can review it. They can decide if they want to put it in or not put it in, and whether we have to maintain a separate. So it works extremely well. Open source works extremely well in that model also.
Great. And so if somebody's buying Hadoop from a consultant, Dave, I think it's a good question to ask how many committers do they have and what's their relationship to Apache, right?
It is. I mean, if you expect your vendor, so there are commercial vendors, we're one of them for Apache Hadoop, that you essentially say, I'm going to treat this like enterprise software, and this company is going to be on the hook to be my enterprise support. Well, if that company can't fix this problem upstream, if they cannot commit their patch back into the core branch, that means you're off on an island. You're isolated, and every time there's a new update, a new feature of Spark that comes out that you want to implement, you also would have to then implement all the changes because they were not able to commit them back into the core project. So that becomes it's one of the reasons why those of us in the open source community talk about committers as being so important, is because those are the people that can solve your problem upstream and make sure that when the next release, your upgrade experience is not something where it's going to break all the fixes that had to be put in place.
Right. Okay, we've got some questions. Bala says, for the end-to-end supply chain analysis, should we maintain the linkage of the master data, or are there more advanced techniques with new approaches to be able to map master data? And one of the things we're testing, Bala, is the rules-based ontologies and cognitive learning to be able to do automatic mapping. That's one of the things we're testing in the network of networks, and we'll be sharing that, but we think that's feasible. Mahoy asked, his 2 cents from 20 years ago, SAP HANA is a faster database, and definitely it is. No question it's a faster database. It uses column-based DB in memory, and so it's a columnar store for faster access. No question about it that it's a faster database for SAP, but the question is, data that doesn't reside in SAP and the relative cost of, the HANA infrastructure and the applicability to the greater supply chain. The supply chain is not defined by SAP data. It's a percentage of the data. And one of the things I would love to see SAP and Oracle support is open source standards so that we can bring in unstructured data and Internet of Things data and be able to use data in a heterogeneous environment. So let's kind of wrap up. How do companies get started? Let's go to the second question. Glenn, if you're somebody and you're sitting in Dell or Procter & Gamble or Monsanto, how do you get started?
Well, we've found that hiring someone who understands the technology and to sit alongside the data scientists. We've had the luxury, and we're here in Silicon Valley, and there's a lot of people out here who understand these technologies, so we've been able to pull in some real experts. If you are in another area of the world and you don't have access, you couldn't hire that, there's certainly a lot of consultants out who can help you get jump started in this area and can get the initial Hadoop stack up and running very quickly, can do the ingest and configure the ingest to be able to import data out of either an existing system or new data feeds you might have coming in from the Internet of Things.
Yeah, and I think it's useful to step back and think about cloud streams and lakes and think about what data should be in the cloud and why, and what data should stream and why, and how you use it, and what data should be in the lakes that we mine. What do you think, Dave? How do you think people should get started?
I always say pick a shiny object, pick an interesting project that you can drive immediate value. So some of these are pretty obvious, like you talk about the fact that we have 3 different, in most companies, 2 to 3 different ERP systems that are sitting out there, each with their own definition of inventory and orders. That is a great starting Hadoop type of a use case, because you want to build a place where you can meld all 3 of those viewpoints together and get a single version of the truth across the enterprise. And so breaking down silos in that way, taking in an external data source that has been of great interest. So you've got telematics providers that are providing logistics information. You're saying, well, what could I do if I knew exactly where that truck was, and what that's going to do to my customer orders or my inbound supply for raw materials, and starting to build those kinds of use cases that just have not been approachable, either from a technology perspective or from an economic perspective. Because again, you get into these open source architectures where the ability to ingest data brings that barrier of entry down so low, you can start to say, I'll take a new data source in without knowing exactly what I'm going to do with it, and be able to explore its value to the organization.
Well, Glenn, every year we hold a conference called Imagine the Possibilities, which looks at supply chain 2030. And, it's a small event, 150 people. And this year we're going to do it at Reynolds Plantation, close to Atlanta. What do you think the role of open source is as we imagine supply chain 2030? What do you think it'll look like?
I think, in the last couple of years, there's been more and more discussions around what you can do to leverage open source to enable these new algorithms. And so I think, I really enjoy those conversations. I get a lot out of it. I get a lot out of working with the attendees there. So I do think, the open source and the ability to, manage this data will become less significant, and the actual applications you're building on top of the next generation of applications that use these technologies, those will be the main themes, and the kind of creative work that people are doing in this area. So, or maybe the open source becomes more the algorithms and machine learning algorithms, or how do you apply the next generation of chips, either NVIDIA or Intel chips, to really get the kind of performance and manage that data.
Yep, the whole move to digital semiconductor technology, I think, is also fascinating. Dave, what do you think the role of open source is as we face 2030?
Yeah, well, I think that the future of reports is in danger. And so if you say that what we're going to do is create the ability for autonomous actions to occur in our supply chain, now it's how do we inform, how do we guide and curate those kinds of processes? So I believe that this community of contributors, they're going to out innovate the standard players that we talk about. There's going to be new innovations that drive around this, and this is going to be on the open source technology. And I think the other piece of that's going to be the concept of an open data model, where we're now talking about let's let the person who builds the best application win, not necessarily the person who's holding all the data.
Yeah, I think it really gets at the whole definition of packaged applications. When memory was of issue and we could not get applications to scale, we believed that we could build packaged applications where we could basically take best practices and we could hire really smart software developers that could give us legacy solutions that would cause the supply chain to work with lower risk. Now, with the ability to do open source, I think we get the combination of packaged applications where we need defined data models along with the ability to use new data to be able to tackle new possibilities. So I think it's really exciting. Any last thoughts, though, Dave, before we sign off here?
Yeah, I think you're starting to see the beginning of that. So for that to exist in 2030, this profusion of REST APIs need to be there so that businesses are able to communicate with one another, to not have to go through centralized data clearing agencies in order to get access, but to have peer-to-peer communication that is secure and authenticated and authorized. And so those models are starting to come into fruition, and that opens up this free flow of data. And the other piece that I think is in there is these sort of self-defining data frameworks. So we talk about JSONs as being a self-defining framework that a piece of data can be communicated in. We say storing it with Avro so that it has schema infused with the data opens us up so that other application frameworks can use that data regardless of where it was sourced from.
Yeah, and how about you, Glenn? What do you think? Any last words of wisdom for the group?
Yeah, I mean, what I'm finding is that it's exactly what Dave was saying. This really enables the data scientist, the person who understands the problem, the person who kind of understands the data or can leverage that data to help build that next generation of applications, and then be able to communicate that out to the business community. We're already seeing that. And again, the self-describing data and being able to have the tools to be able to leverage that self-describing data to build actionable or actually take actions in the supply chain. That's where we're going, and that's where the industry is going.
Yeah. So we have a question from Manoy in Toronto. He says, here's a real problem. He has a pharmaceutical client, so let's assume he's a consultant. And he asked the question, is the Hadoop stack a solution to create a data pool if you have multiple ERP systems like SAP, ECC, JDA, JD Edwards, and different business units, and also want to bring in planning data like SAP APO and JDA? Is the Hadoop stack a good fit? And I think it is. For both the rules-based ontology for cognitive learning for master data, for data pools, for queries, for Spark, for streaming data. What would you say to him, Glenn?
Yeah, no, absolutely. And that's exactly what we're doing as a part of an S&OP process with the what-ifs and being able to build these scenarios very quickly. We aggregate data. There is a little more work to do as you're trying as you aggregate that data to be able to, we call it normalizing it and being able to make it to where it kind of all fits together. But that's exactly where we have our stack deployed or used by multiple customers that are doing that very thing.
Yeah, and Dave, I don't want to speak for you, but Cloudera actually offers some of this for free. How would he go about finding out more and perhaps actually testing it?
Sure, and not to be plugging the vendor in this, but if you go to cloudera.com, there you can download the distribution for free and start and use it for as long as you want. I mean, that's the beauty of the open source license with Apache 2.0 is use the software as long as you want to. The other thing that you'll find is lots of information up there. We've got very rich blogs in our engineering section. So if you wanted to tackle a very specific problem there, say, how would I build a streaming ingest using Spark and Flume and Kafka? If you search for that in the blog section, you'll find code snippets and examples of exactly how to get started there.
Great. Well, I'm going to wrap up the webinar. I hope people will put the Imagine conference on their calendars for September 5th through the 8th, where we'll come together and build a guiding coalition. But also people have said to me, Laura, what you talk about is just so different than what we see at our company. And we've actually built training classes with CorpU where we're asking people to imagine the supply chain of the future. And we have a cross-company academy starting in May. And the cross-company academy is designed for 2 to 3 individuals from each company. And we're going to go through the 7 online courses, and we're going to ask ourselves about how S&OP will change in 2030 and how market-driven value networks, which are outside-in processes, and how to make the digital pivot. And the concept is that we'll have a North America, European, and Asian cohort of people across companies that can imagine together and ask each other questions and talk about use cases. The other thing, and this is $2,500 a person, which allows people for the online learning, and the online learning is 45 minutes for a week during the month. So 4 days, 45 minutes, followed by a live event. And then if you want office hours with me or other people, then we can arrange that. And then we have the ability to go into a company. So some companies don't want to join the cross-company cohort, but they'd like to do the training within their company to kind of jumpstart their thinking in supply chain. We have a course that's designed for a company for groups of 30 to 50 that allows people to take this online learning over a week for each of the classes, and it's priced based upon the number of classes that people take. And it combines social engagement with case studies and ideation and short videos, and allows people to really ask themselves the question about how do we redefine supply chain processes. I want to thank people for joining us on our webinar today. You know, we're committed to helping to unstick the supply chain. 88% of companies are stuck. We're trying to help supply chain visionaries to take advantage of new technologies, ask questions about traditional processes to really drive value. We share all of our research online in an open source community. We're trying to redefine the supply chain for the global organization, and you can follow us on these websites and in our community called Beat Fusion. And if you want to follow me closer, you can follow my LinkedIn profile. I write weekly on LinkedIn on a blog, and I also write on a website called Supply Chain Shaman, and I write for Forbes. We thank you for joining us today. I hope you have a good week, and we hope to see you on our next webinar next month. Thanks very much. Helen?
Thank you, Laura. And thank you, Dave and Glenn, for being with us today. Again, I'd like to thank everyone who joined us. A few things just before we wrap up. As I mentioned, we will send the slides and recording link to everyone on this webinar, so keep an eye out for that follow-up email. We also encourage you to follow us on social media, Twitter, join our LinkedIn and company page, and follow us on SlideShare. And this information is on the slide deck. Thank you.
Thanks, Glenn and Dave. Bye now.
Thanks, Sean. Yeah. Laura.